This is my forces in circular motion reassessment. The problem is a 540 kilogram car is merging onto the interstate on a banked curve. The curve is banked 7.1 degrees from the horizontal and is rated at 35 miles per hour. The car takes a turn at 52 miles per hour or 23 meters per second. What sideways frictional force is required between the car and the road in order for the car to stay in its lane? The radius of the curve is 210 meters. So, drew my diagram, then I drew my force body diagram. Started out with summation of the forces is equal to mass times acceleration. Broke that up into its x and y components, and similarly I took the friction force with its x and y component and the normal force and its x and y component. Mg just has a y component, so that's why it's over here, not over here. Now, f of forces in the x direction are equal to the mass times acceleration in the x direction, which acceleration in the x direction is v squared over r, which when you multiply that, that's m, and then negative m, now you have your friction force with your x component, your normal force with your x component, plug in what you know, get the number. Now you have this, so we're going to solve for n, which we move friction force over here, and then once we solve for n, we get this number, because we divided by sine of 7.1, divide each by sine of 7.1, this is what we get. Now come over here, take the y component of each force, plug in what you know, and I moved it, plugged in mg and then moved it over here, so then we're left with this. So this in here, took this and plugged it in here. You plug it in here, you multiply by cosine of 7.1 to each term, and you're given this, and then multiply sine of 7.1 is that. And then you're left with this, so when you subtract 10,918 from both sides, do it here, you're given negative 5,610 newtons, and then once you add these two negatives, you're giving negative 8.09, and then once you divide by that, you're given your friction force, or the force that is needed, and that will be in newtons, and it will be positive because negative divided by negative is a positive, and so our friction force is 690 newtons.